Hi guys, this is video 2 of 3. It's March 13th and we're taking notes on properties of logarithms. There's 4 properties in total. We're going to talk about the properties, how to prove that they work, and talk a little bit about how they're similar to exponent rules. First property states, if we're given log base b of m and told that it's equivalent to log base b of n, then we can assume m must be equal to n. This is kind of common sense. If you're given 2 logarithms and told that they're equal to each other, their bases are the same, then their arguments have to be the same as well. It's really important to confirm, though, that you're always given the exact same base. It's kind of similar to exponent rules. If you're told that x squared equals x to the sum power, well, if both of the bases are x, then obviously their exponents have to be the same too. It's like saying 2 squared equals 2 to the something power. Well, if 2 squared is 4, then n has to be 2 as well in order to make these 2 statements equivalent to each other. N equals 2. You're going to notice that these logarithm properties are really similar to the exponent rules. That's true for all of them. Property 2. Property 2 states that if we're given log base b of m plus log base b of n, we can condense these 2 logarithms into one log by multiplying their arguments together. Log base b of m plus log base b of n equals log base b of m times n. That might sound familiar. It's really similar to the exponent rules. We know exponent rules say that if you're given x squared times x cubed, as long as the bases are the same, you're allowed to add the 2 exponents together. So there's some similarities there to exponent rules as well. Property 3. If log base b of m minus log base b of n, you can condense these 2 logarithms by dividing their arguments. Log base b of m divided by n. Again, really similar to exponent rules. You're told that if you're given x to the something power over that exact base to another power, you can subtract their exponents. So you see there's a lot of similarities to exponent rules. Think of it like this. If you're adding, you can condense them by multiplying. If you're subtracting, you condense them by dividing. Very similar to exponent rules. When you're multiplying, you add their exponents. When you're dividing, you subtract them. Property 4, this is the last property. It states that if you're given log base b of m raised to a power p, then you're allowed to take that power, move it all the way to the front of the logarithm, and multiply power by the logarithm. Those 2 statements are equivalent to each other. Okay, so these are the 4 properties. You can kind of highlight those or put them on a note card. Let's talk a little bit about why they work. So we're going to confirm the log properties. That first log property is really self-explanatory. If the logs are equal, the bases are equal, then the arguments have to be equal too. So moving on to that second one, it says that if you're given log base 2 of 4 plus log base 2 of 8, that we should be allowed to condense those 2 logarithms by multiplying their arguments. In other words, log base 2 of 8 times 4, or 32. Let's see if this is true. Ask yourself, base 2 to the something power has to equal 4. Base 2 to the something power has to equal 4. Well, in this case, that x has to be 2. For this piece, log base 2 of 8, you're asking yourself 2 to the something power equals 8. Well, that x in this case is a 3. 2 cubed equals 8. So log base 2 of 4 is 2. Log base 2 of 8 is 3. Let's look on this side. I'm asking myself 2 to the something power equals 32. 2 to the what power equals 32. In this case, x has to be 5. 2 to the 5th power is 32. Well, we claim that log base 2 of 4 is 2, log base 2 of 8 is 3, log base 2 of 32 is 5. Does 2 plus 3 equals 5? Yep. In other words, that property holds. Okay, maybe it'll start to make a little bit more sense when you see the second example. I'm going to use log base 2 of 32 minus log base 2 of 16 equals log base 2 of 2. The property states that as long as the bases are the same, they are 2 and 2, if you're subtracting two logarithms, you should be able to condense them by dividing their arguments. 32 divided by 16 equals 2. Let's see if it holds. 2 to the what power is 32? That's 5. 2 to the what power is 16? That's 4. 2 to the something power equals 2? That's 1. And does 5 minus 4 equal 1? It sure does. So I'm basically choosing values to plug into my properties here and then confirming whether or not they hold true. So far, so good. Last one. We're given log base 3 of 3 to the 4th power. Hi, Hazel. That's my dog, Hazel. Sorry. We're going to take this exponent. Hazelnut, stop. We're going to take that exponent, move it out front. 4 times log base 3 of 3. Let's see if it holds. So I'm saying 3 to the something power equals 3 to the 4th power. 3 to the something power equals 3 to the 4th power. Well, that's 4. 3 to the 4th power equals 3 to the 4th power. She's very upset about something. I don't know what. On this side, we're going to multiply 4 times log base 3 to the something power is 3. That's got to be 1. 4 equals 4. Yes, it does. All right, I'm going to deal with my dog. This is video 2. You got one more to watch, and then you're done.